Let's look at our giant apparatus for producing molten regolith on industrial scales on the moon. It's for an advanced colony, obviously, and couldn't be made without advanced robots to do the construction, and is meant to serve a colony with thousands of people that has the industrial infrastructure that needs the kind of lava that would be held in this tank, which holds 1,700 cubic meters, to make all sorts of things like any kind of glass product and cast stone products, and to supply reactors that extract metals, and in construction to seal and join things. So these mirrors are parabolic mirrors, and each one focuses a full megawatt of energy all day long on those pipes going through the focal line down the center there. These pipes are filled with sodium vapor, that's the heat carrier, and they're made of fused quartz, and they glow white hot during the day, of course. So some of the heat that bears down on them is lost pretty quickly as light, but the rest flows away and is protected from heat loss on the rest of its journey back to the lava tank by many layers of metal foil with vacuum in between. So the radiant heat loss, which is the only heat loss in space in a vacuum, is reduced because on the outer layers, when it's cool enough that the silver won't melt, silver is a great insulator for this. You can hope to get 98 or 98% of the light reflected back towards the pipes, and if you do that enough times, you aren't losing very much on the journey. And then those sodium lines get to the giant lava tank with all its infrastructure. Its insulation layer has been stripped off so we can take a good look at it. Inside this torus, the sodium pipes shed their heat to the liquid aluminum that makes up the rest of the system here. And these pumps, each one manages one of the pipes that transfers the liquid aluminum in this torus down into the lava tank. Here there's also the chute that's used to fill up the tank with fresh regolith before dawn. And there's this pump, which is used to pump the trace atmosphere of trace gases that are still valuable off the molten mix and store them away so that they can be used for other things: the sulfur, the carbon, the hydrogen, the nitrogen. And this radiator is used to chill the sulfur so it solidifies here, and then the remaining gases would be pumped into these side tanks. Inside the tank, there's a mess of pipes. I stripped away some of them because they just become a confusing jumble. The liquid aluminum makes a good long trip in here to shed all of its heat and distribute it evenly. And each one of those circuits has a scaffold so it doesn't snap, and that it can be removed for maintenance and repair. And this middle point should allow a convection current to be set up in this massive volume of runny lava, so that all of the gases escape through the surface and are collected through this to that pump and all the stuff that I talked about up there. And then there's a whole bunch of other pipes as well. Lots of pipes. all of these pipes that are collected from this gigantic stone mass, let me hide half of it here so you can see the inside of it. They're collecting the gas from these winding pipes, which aren't actually really pipes. They're voids in this cast stone mass, which would be made of forsterite blocks left over after processing of olivine for glass and maybe for iron production. The reason why this huge stone mass has been incorporated is so that if you chose not to empty the tank overnight, the latent heat of it solidifying and also the heat stored up in this mass would be enough to run the Stirling generator all night long at a pretty good power level. And that also works better because outside of the stone mass is this another thick layer of powder regolith, which insulates heat loss from it. Stirling generators are a great option for space because they work on a closed system. The hot end is fed from the nitrogen gas that comes out of these pipes up here and along here. And the heat of that expands the air inside this chamber, which drives its piston back. And when the piston moves back, let's run the animation. The crank turns and that pushes this piston back, which expands the gas inside of it, which draws the gas from here to there. And this is the cold end, and both the movement of the pistons and the radiator, which is over here, is cooling that gas, and as it cools, it contracts, which pulls this piston forward, which turns the crank more, which moves that piston forward, and you have a virtuous cycle here, and it just keeps going. And that turns this rotor, which is a gigantic magnet, and as it turns, it induces electric current in this stator, and that's how generators work. So the cold end of the generator is connected to this heat exchange tank, which goes to this heat exchange tank. There's the large tank in between because this is designed to have more than one generator and radiator unit on the same lava tank. And I've hidden half of the small tank so you can see if you can get to the right place at the right time. The coils in there pick up heat from that fluid and send it to the compressor, which forces it as a high pressure gas up into the radiator panel, which causes it to really want to change state from a gas to a liquid. And as it does that, it sheds a lot of heat to the metal of the radiator panel, and then that is released as infrared light, which reflects off the foil surrounding it and goes into the cold of space. So let me just stop this animation and fly around here. So this radiator unit can potentially chill to temperatures even below freezing because sunlight can't hit it over the course of the day, and it's also protected from the heat of the ground, which on the moon can get very hot. It gets up to 120 degrees Celsius over the course of a day. Just by turning the radiator panel so it always lines up to the sun like this, edge on, almost all the heat of the sun can be protected from its surface just by doing that. But if you want to keep the heat of the ground away, you got to surround it all. And so the only way to then prevent the heat from above from landing on the radiator is to put a parabola shape in here so it's all focused to a point above the radiator panel, somewhere out here. So that's how this whole scheme works to produce monstrous amounts of lava and build all kinds of things on the moon, including cities. And the way things are going now with technology, this is the way to go. And ultimately what we'll do is we'll settle the moon first, because that way we can use intelligent robots like are now coming online to make huge fancy things like this and have them operated from Earth and not put any people at risk. And then you have a huge place on your doorstep that can get you to anywhere else in the solar system really, really well. And it can even do business with Earth, or at least in the space around Earth, building space stations and spaceships and satellites, and doing even really fancy things like building skyhooks. So thanks for coming and learning about this. And if you want to know more about structures like this and how we're putting them all together for our virtual lunar colony, please visit moonwards.com.